time he'll be spending is on reading the code, followed by modifying the code, and less time he'll be spending on writing the code. So actually the graph has to be vice versa. So if we follow all the practices in place, most of the time he'll be writing the code, less time he'll be working on debugging or modifying the code, and the time he'll take to read the code will be drastically less. So that is where we get more efficiency on writing codes. That is how we work, right? So that is what the importance this graph is going to show us. So with this, we'll move on to the other important rule called voice code rule. So Uncle Bob has stated this voice code rule, which is quite famous. So what the Americans usually do is they used to clean the campground before they leave. So they ensure that the campground is clean when they enter back to the morning. So he is actually trying to compare this voice code rule with the clean code practices that we wanted to do. So if we all check in the code with bit cleaner than we checked it out later, so the code will always going to be cleaner and much efficient. It is not at all going to be rot at all. So one thing that we wanted to keep in mind when we think of a voice code rule is we wanted to have all the code much cleaner and efficient. Here we'll come to what is refactoring. So refactoring is basically modifying the internal code structure to eliminate the poor design pattern without affecting the external behavior. So when and all we'll be using refactoring. So first thing is whenever we wanted to improvise the existing design, we'll be using refactoring concepts. Fixing bugs and adding new features, we'll be using refactoring. So we do peer reviews, we do code reviews in case of any major code changes, or in case of any new enhancement, we used to do feedbacks, right? So in that case, if there is any legitimate review, we will be doing refactoring. The other major thing that comes into picture is code smell. So code smell is going to be the entire thing that we'll be discussing in the upcoming slides. So the next slide is on what is code smell. Code smell is basically the symptom that we identify in our code base, which indicates that there is a severe problem in the fundamental way of writing code. Of course, code smell is not at all a bug. These kind of code smell can be seen in the existing framework or existing code base that we work on. Even though it is present, all the unit tests or all the end-to-end tests or all the UI tests that we have will successfully pass without any failures. But the problem is these kind of code smell these kind of code smells introduce a lot of new bugs, which we may not even expect at all. And these code smell introduce a lot of tech debts if you are not going to maintain then and there. And whenever we have a code smell, the first driver that we wanted to think in mind is on refactoring. Even if you are not refactoring here, then it is going to be a lot of mess. We may end up in creating a new framework. So if we are not considering the little bit of refactoring effort when we identify a code smell, later point of time, we may end up in creating a new framework, because the total time it is going to refactor the existing framework by eliminating the poor design is going to be drastically high. And at the same time, if you are not thinking on eliminating the code smell, then we may end up in writing bad pattern of code in the work that we do. Here we have a picture representation on the importance of eliminating the code smell. So there is a conversation happening between the monster itself, a code, and a developer. So he identifies a code where he's not sure what is happening or where it is being used. He's not sure what is happening inside the code. So he's not sure. He doesn't have any clue. So what the monster is replaying is, if you do not have any clue on what is happening, just do refactor. Again, this is one of the key points. So the reason why we are bringing in refactor is that if you identify a code, we wanted to do refactor. It doesn't mean that only the author of the code has to do refactoring. It's our individual responsibility to refactor. So if we identify a code smell, and even if that particular block is not written by us, it is our individual responsibility to make it clean and proceed further. So that is what one of the key takeaway when we wanted to take it by understanding this picture. So with this, we'll get started with demo. So as I said earlier, we have categorized all the code smell into two parts. One is from the programmatic perspective, and the other one is on UI perspective. So the first category is on dispensables. So dispensables are the unused code that we find it in our code base. It can be anything. It can be a method, or it can be a variable. It can be anything. So anything that is not used, we consider it as an unwanted code, right? So eliminating those code help us to make the code much cleaner, efficient, and much maintainable. So what are all the dominant categories that comes under this dispensables are comments. The other one is dead code, and the other one is duplicate code. So we'll get into the demo now and understanding what comment code smell is all about. So it's really writing comment a code smell. So we may have a question. So we used to have all the comments in place whenever we identify an API or whenever we explore into our code base, we used to see a lot of comments, right? Is comment really a code smell? This question really make us shock. So it depends on the intention in which we really write the comment. So what are all the symptoms in which we can consider this as a code smell is that if the comment that we write in a variable or before a method or before a class, which intentionally describes about the behavior of the functionality, then it can be considered as a code smell. Of course, there are certain exclusions in which we can still write it. So the one thing is, if we do not have a control on making the code cleaner or readable, we can still add comments. In some situation, we may be working or we may be creating an API which will be exposed to the outside of world where we wanted to pass in some of the license related information. And still in those cases, we can still add comments. So the first example, we'll see what are all the areas in which we can find the symptoms of comments code smell and what are all the areas in which we can still add comments. So here we have a class called email validator, which is responsible for validating the email address. We can see we have email addresses being passed here. So here we can see a comment is being added, which in turn describes about the internal behavior, like what is the parameter, what is the return time, and what is the what this particular method is trying to do. So with this, we can understand that this is trying to represent the internal behavior of this method. So before that, we also have a regex pattern where the comment is being added here. So one thing that I said earlier is that there are certain areas where we do not have a control on making the code cleaner. So one such thing is regex pattern. So we know regex pattern is a powerful engine, and most of us may not be aware of what these kind of patterns are trying to do. Even we will not be able to make this code much readable, as this is how the pattern works. So in those kind of areas, we can still add comments like this. And we'll also see what are all the other factors which dominantly affects the readability of the code. The one is the poor formatting. So since the class is pretty much small, we can still understand what is happening. If the class is going to expand day by day, and if we still have these kind of poor formatting, then it is really going to be a mess, and we'll not be able to understand what is really happening. The other one is the usage of Hungarian notation. So Hungarian notation is basically a prefix that we add before the variable declaration here. So the thing is, since we already have a data type of string here by representing it as a variable name here, it is not needed for us to have an Hungarian prefix added before the variable. In long term, initially we may consider this as useful, but in long term, if we still have Hungarian notation, it's not going to work out at all. Of course, it is going to affect the readability in long term. So what is the solution, or what is the impact it is going to bring? So we were discussing something about the readability and maintainability, right? Of course, this kind of code is going to really affect those factors. So what is the solution for this kind of code? For formatting related issues, we wanted to format the code as per the project standards or as per the ID standards that we currently have, and to bring in proper naming convention. So the way in which we can eliminate the comments is that the code that we write should speak itself. So how do we make it? By proper naming conventions, right? So here, initially we had a method called validate, where we were not able to understand what is really happening. But while we're trying to create proper naming convention for methods and for the variables that we write, we can really understand even without having a comment, right? So when someone comes into the code base and look into the method, he is sure that he can understand that what is happening inside this. So something we are trying to pass in, and he can understand something it is going to return. So he can really understand this. So here in these kind of areas, when we write the code with proper naming convention, we can really make the code much readable. And for the areas where all we are just using it for only once, we can bring in constants. And here in this example for regex pattern, we can bring in constants and bring in proper naming convention as well. So these are some of the techniques in which we can bring these kind of codes much readable. So with this, we are end of comments. We'll quickly jump into what is duplicate code and dead code, and we'll have a initial level of Q&A. So from the name itself, we can understand any variables or any method or any class that is not being used anywhere can be a possible dead code, right? So in the other point of view, whenever we find the same kind of code which is repeated in multiple places, here we call it as duplicate code smell. Not only the unused methods or classes is considered as a dead code. Any condition or any catch block that doesn't even execute is also considered as a dead code. So in this example, we'll combine these two and identify what are all the where all the areas where we can consider it as a code smell symptom. Here we have a class called people service, which is responsible for finding a person. So it takes in a string array, and it also takes an age. So we have a case condition here, which is trying to perform the equality of the person that we are passing in. Now we can understand that the same if condition is being repeated in multiple areas, though the data value that we pass is different, but the condition is going to be the same. So here we call it as a duplicate code. And the other area, we can see that we are using try-catch here with multiple cache blocks. So this particular cache block is not at all going to run at all, because here in this time, so here in this case condition, we'll not even get the arithmetic exception. Though it is here, we consider it as a dead code. Coming back to the lower part of the code, we have a method called toLowerCase, which is not used anywhere inside the code base. Here we call it as a dead code again. Coming back to the parameter here, we have int age, which is not used anywhere inside the code base. Even these kind of parameters can be considered as a dead code. So what is the impact it is going to bring in? So if we have all these kind of practices in the large class, or if we have all these kind of code smells in the larger class, of course, it is not going to, of course, the maintainability is not going to be easy. It is going to be very challenging, right? So what is the resolution factor for these kind of code smell is that for the duplicate code, we wanted to evaluate multiple algorithm factors and to choose the best one, and we wanted to replace it with a substitute algorithm technique. And for the dead code, we have multiple editors. We have various tools which helps us to identify the dead codes. With the help of those, we can easily remove it. So here in this case, we brought in all the data as a list here, and we are just using the list contains to validate the condition. So by using this kind of algorithm, we drastically reduce the number of times we use the if conditions here. So from this, we can easily understand and easily visualize the code is becoming much clearer than the one that we saw here, right? So here we have the number of lines is high, which is the another cause of bringing in another code smell. So here it becomes much cleaner. So that's about duplicate code and dead code. So before moving to the next category, would like to take any questions. Okay. So guys, please feel to add questions in the Q&A. We'll try to answer then and there. So Kapileson is going to watch the Q&A. So if there is no question, we'll go for the next category. So next category is of blotters. So blotters are basically the classes and methods which are of huge in size. So whenever we create a new project or whenever we create a class, it's going to be in small in size initially. So if we do not follow all the clean design patterns in place, of course, it is going to end up in large in size, right? So that is what this blotter category is going to say all about. So in blotters, the first code smell is large class followed by long methods. So writing a large class is definitely a code smell. There are certain symptoms in which we can understand. So there are various criteria in which we can determine whether this class is a code smell or not. So for large class, if we have more number of instance variable, or if we have more number of methods, or if we have more line of code inside the class, there is a high chance that this particular class can be considered as a code smell. The other determining factor in which we can take is that if the class is doing multiple responsibility, then we can definitely consider it as a code smell. So what is meant by multiple responsibility? It is basically the single responsibility principle where a class should have only one responsibility to allocate. And for the long method, so any method that has more than 10 number of lines, there is a high chance that this method can be considered as a code smell. So even there in long method, there are certain determination factor. If the method is trying to perform multiple action, definitely we can consider it as a code smell. So we'll take a demo and understand where the code smell for long class and long method is occurring here. We have a class called college admission, which is trying to create the admission for the student, which is also trying to perform the action of adding the student to the department. So for the college admission class, adding the student to the department is a completely different responsibility, right? So we already have a method called add admission. Adding the student to department is completely a different responsibility. So with this symptom, we can understand this particular class is a large class sportsman. Deep diving into the method, we have create admission here where the number of line is greater than 10. So of course, I'm going to keep an eye on it. Looking into the method, I can see there are various actions being performed. So one is it is trying to fetch the fees. It is trying to add the student into the department, and it is also adding the student related data details in a text file. So here in this method, we have three different actions which is being performed. So considering these factors, we can clearly understand that this method is also a long method postman. So what is the impact it is going to bring? So initially, if the methods and classes doing a single is doing a simple or less responsibility, it may be difficult for us to refactor. So if the class is doing multiple responsibility in case of any refactoring work, then it is really going to create a mess and the maintainability factor is going to be affected. So what is the solution for these kind of code smell is that? So first thing is to delegate the responsibility, and we wanted to introduce single responsibility principle for the college admission class that we have. So we brought out the add department method to a separate class called department. Here we brought in all the department related functionalities. And for the data type variables, we created a separate class called student and department where we brought in all the instance variable to those class, and we are just passing it as a parameters to the college admission class. And for adding the students to the text file, we brought in another class called student admission details where we are storing all the student related details in a separate class. And we are just passing in the reference inside this method. So we are just passing in the reference inside this method. So by doing this, the one thing that we get is we are following the single responsibility principle, and at the same time, we are drastically reducing the number of lines in the method that we have. So now the code is looking much cleaner, and the class is just doing a single responsibility. So this is the solution factor for these kind of long class and large method postman. So with this, we'll move on to the non-parameter list and followed by the data claims as a postman. So from the name itself, we can understand any method or any constructor which takes in more number of arguments can be a possibility of postman. So what is data clumps then? So if we have more number of data types of same group which are completely identical, which doesn't survive without one, then it is a possible data clumps postman. So in this example, we'll see where we identify the long method or we'll identify where the long parameter list occurs. So we have a class called booking service, which is trying to book a ticket. Looking into the constructor, we can see we have more than 5 parameters, right? So the impact that we have if we do not clean these kind of long parameter lists is that whenever the client is calling the booking service class, if in case if the client is trying to send the data in an incorrect order, then we may end up in a mess. So we may introduce a lot of unknown issues, or we may introduce bugs as well. So this is one of the important criteria which makes us to reduce the long parameter list. And what happens if we do not clean these kind of data clumps code smell is that. So if we do not clean this kind of data clumps code smell, as the class getting expanded, we may introduce much more data types like this, which may introduce another code smell that we saw in the earlier slide, which is large class code smell. So it is important that we clean up in the beginning stage itself. So what is the solution factor for these? So the one thing is we wanted to create a separate data class for all the group of variables that we saw. So here we can see a group pattern, right? So from to depart date and return date. So this can be a possibility of group. So we brought in a separate class called journey details, and the name and age is another group pattern. So we brought into the passenger class here as a data class. So we are just bringing in the reference to the constructor here. By doing this, we are drastically reducing the parameter list from 6 we brought into 2. So this is how these kind of long parameter list has to be taken care. So there are still situations where we can still extract the long parameter method to a single box of method. Even by doing that, we can reduce the parameters that are available in a method. So this is the solution factor of long parameter list and data clumps. So we'll move on to the next code smell called primitive obsession. So primitive obsession is one of the dominant factor which contributes to the blotters. So what is primitive obsession is that whenever we use more number of primitive data types to represent domain related model variables, it is considered as a portsman. So what is domain related variables? So here in this example, we have a class called water service, and which takes in three parameters. One is the name, the other one is age, and the other one is the constitution. So comparing to the programming language that we are using, for age, it is going to be the number. So still we are using int age. But looking into the domain that we are working on, water service, which is not at all matching. The reason is that in domain water service, the age should always be greater than 18 and should always be less than 120. But in case of the programming language that we are using, an integer data type can contain multiple range of values. It can contain both positive, or it can contain both negative. It can even contain greater than 120 as well. So if you are not cleaning these kind of codes well, the impact that you're going to get is we will be using multiple validation points whenever we use these kind of variables. So in this example, we are using this age data type for casting vote. So before casting a vote, we are just trying to validate whether the candidate is eligible for casting the vote or not. So similar for that, we have constitution, which is also against the primitive obsession Portsmouth. The reason is that not in all situations, all the constitutions are eligible for vote. It depends upon the area. It depends upon the location in which the voting is happening really. So what is the solution factor for these kind of Portsmouth is that we wanted to introduce the separate data class, and we wanted to bring a separate setter method to validate all those validation in separate class. So we'll move on to the cleaner code part here. So we have the voting service class here with cleaner code. So we brought out this the age int age as a separate class called age. Inside the age, we are bringing in all the validation related to the age. So here we have a setter class, and we are trying to validate the method here. So if the age is greater than 18, or if the age is lesser than 18, automatically the exception will be thrown. So the one advantage is that whenever the client is using the voter service, he'll be defining the age before accessing the voter service itself. So it is not needed for us to access all those kind of validation inside the code base. Now we have excluded the validation part from the casting vote, and we brought in the age class itself. So that's the solution part for these kind of primitive obsession. And with this, we are end of Blotters Sportsmill. So before moving on to the couplers, is there any question we would like to address? So Kapileson, is there any question that is unanswered in the Q&A?
No question.
Okay. So I'll consider it as no. We'll move on to the next Sportsmill called couplers. So when we hear about couplers, we can understand that is tightly coupled. So what is tightly coupled basically? So whenever an object is tightly coupled with multiple objects, it is called as couplers here. So one of the predominant factors that contributes to the coupler is messaging chain or method chain coding, method chain codesmell. So we usually see these kind of method or message chain is happening whenever we use programming languages like Java. So even in the string buffer, string builder, we used to chain a lot of methods to perform different kind of actions, right? So we may have a question like, is chaining is really a code smell? Of course not. It depends on the situation, or it depends upon the symptoms in which we are using it. So we'll discuss some of the symptoms from which we can consider message chaining is really a code smell. So the thing is, whenever we try to perform a chain that has multiple objects involved, it is definitely a code smell. So in this example, we have a class called invoice, which is trying to calculate the total shipping price here. Sorry, total price here. So the calculation part here is that whenever the product is going to be shipped outside of India, we are trying to do an arithmetic operation here. So in order to check whether the customer shipping address is outside of India, we are actually trying to do a message chain with multiple objects in place. So the customer object now is in touch with get address class, address class, and this address class is in touch with country here. So here this customer class is tightly coupled with two different classes, right? So this is what we call it as couplers message chain codesmell. So what it is going to impact? So it is going to impact the law of Demeter. So law of Demeter says that the object should have a relationship only with the nearby objects. And if the object is having multi-level relationship, then it is really a codesmell. So how do we resolve these kind of codesmell? Is to delegate the tightly coupling to a loose coupling way of approach. So we'll look into the solution part now. So now what we made is we just made the customer class to interact only with the address object here. So inside of address object, we can see that this address is going to interact with country. And from country, we can bring in whether the customer is outside of India or not. So from this kind of solution, we can understand that we are delegating the tightly coupling way of message chain to the loose coupling way of message chain. So that's all about couplers. So any question, folks? So before handing it over to Kapileson, would like to take any question. So I'll consider it as no. Over to you, Kapileson.
I have a question, Kowcik, on the route we're taking. So are we going to do hands-on now before we jump into the next one?
So we have the hands-on post lunch, I guess, side. So we are just trying to explain about the code smell from program perspective and as well as the UI automation perspective. So Kapileson will be discussing some of the other code smell, and he'll also be explaining about the UI automation related smells. So over to you, Kapileson. Yeah.
Yeah. So before that, any questions, folks? I know we saw many code smells, which could be confusing you as well. If there are any questions, please feel free to ask. Okay, so I think we can move on to the next categories. So the next category of code smell is the change preventers. So the change preventers represents that if you want to make a change in one place, right, you have to make change in many other several places as well. So the development becomes much more complicated as well as the expensive. So let's see what are the code smells in this category we have. So the first code smell is a divergent change. So what is a divergent change here? So what is it's going to indicate, right? So when you have a class where you want to add a new feature or modify the existing methods in a class, right? You will find yourself in changing that class for multiple times for the different reasons. So this is the indications for the divergent change code smell. Let's quickly see in the example. So this is a account service class where I have a few methods like a deposit, withdraw, and loan interest rate, and few email notification methods as well. So these methods, deposit will do a deposit into the account, and the withdrawal will do the withdraw action, and the loan interest rate will set the loan interest amount over here. So if you see, right, if I want to change the loan interest rate of gold loan, right, from a 10 to 15, I'll make changes in this piece of method. Likewise, if I want to change the withdrawal limit from 5,000 to the 6,000, right, so I'll need to make changes in two different places. Also, you can see the another code smell over here, which is a duplicate code, right? So this condition has been used in the two different places where we need to extract that into a different method, right? So anyone could tell me what violates this? If anyone would have know the solid principles, right, or anyone would have heard about the solid principles, can anyone guess what violates this divergent change here? Anyone? So I can put a question in a different way, like in a solid principle, what is S pointing out? Yeah, Shubham. Yeah.
Single responsibility.
Exactly. If you see this class, right, it has multiple responsibility in it, right? So it is doing a deposit, it's doing a withdraw, as well as it's doing, it's setting up the interest rate as well, right? Also it's doing the notification, sending a notification as well. It has a multiple responsibilities, which is a code smell. That's what's the divergent change here, right? I'm making multiple changes in the same class. I'm often disturbing this class for every changes I need to make, right? So what could be the solution over here? Anyone? How we can make this class more responsibilities, right? How we can make this class holds the one responsibility, right? So I can tell you what the single responsibility principle tells, right? So it tells like a class should have only one responsibility, and that it should do that well, right? And a class should have only one reason to change it as well, right? Like we see, we have multiple reasons to change this class. So what could be the solution for this? How can we refactor this? Anyone want to try? Yeah, again, Shubham, come on.
Parent child kind of inheritance we can create, or we can create some kind of helping class module. We can create some modular classes, so if that needed we can inherit it otherwise, or we can call it, or otherwise we can.
Exactly.
Yeah.
So one thing is like we can't inherit these responsibilities because we can't inherit the notification to the account service, right? That's, if you see this, notification can't be a child for the account service here, right? So both the account and the notification loan things are the different entities over here. So the refactoring technique could be here is the extracting the class into the different classes based on its responsibilities. So let's see how we have done here over here, right? So we have the same account class where we retain the deposit and the withdraw method. Why? Because it aligns with this account service name, right? So it holds a single responsibility over here, right? So I just moved this loan interest calculator method to the new class, which is a loan service, right? Where I am calling the account service to have the aggregation between these two classes, right? So again, I'm moving the notification related methods to a new class, which is a notification service. And I also extracted that duplicate group to a new method, right? So if you see here, it's more readable. When you see this method, we are seeing the condition like, oh, it's withdrawing the withdraw limit. Okay, so if it is passes, it's going to send a notification over there, right? So when you see this bad code, it's not readable like that, right? If you see here, we need to understand this by for everything. What is this and what is this condition over there, right? So this is how we extracted this class and make justified the single responsibility here, right? So any questions? Someone asked. Okay. So before moving to the next code smell, I'll pass here for any questions here. Come on, folks, you can, I hope there will be many questions. I hope there will be hesitation for asking that. Come on, feel free to ask any questions here. Okay, so with that we can move to the next code smell, which is a shotgun surgery. I hope here comes the questions because it's a little bit confusing when you compare with the divergent change. Because shotgun surgery resembles the divergent change, but it's completely opposite to that smell, divergent change smell. Because in the shotgun surgery, the symptoms would be when you have to change small piece of code in a class, you find yourself in changing in several classes at the same time. Like if you would have duplicated the code in the many places where you have to make changes in different classes. Also, sometimes when this code smell occurs, right, sometimes you misunderstand the single responsibility principle. Right? So yeah, so when you misunderstand the single responsibility principle and try to separate the classes irrespective of these responsibilities, which means the separation of the core logic when you did, right? So I just took a same example what we seen in the divergent change, the account service. If you see the account service, right, I have a few variables over here which is related to the account service and the getter setter methods, as well as some display method. So now before that, I just want to tell you like, so it looks like a data class, right? So data class is another code smell which comes under the blotters, which tells like when you use a class only to store a data, right? That's a code smell again. We often use in our framework, right? We just have one class where we will have many variables and use a getter setters to access that and set up the values over there, right? So it's a data class which we always should avoid that, because a class which is used only to store a data, that's actually a code smell. We should not do in that way. The class should do some functionality over here, right? If you ask this class is displaying the account information over here. So this we can't consider as a data class. It's a clean code over here. Okay. So coming back to the shotgun surgery code smell. So this account service, we have the variables which is specific to the account service, and we would move the deposit service. If you see, that is available in the different class over here, right? So in this, we have a condition like if the amount is greater than 500, we have to do a deposit. Okay, so likewise, we have another withdraw service where we are doing a withdraw action where we are having the same condition over here, right? So just assume like if I want to change this cap, right? So 500 to 1,000, I need to come change over here as well as in the year, right? In the withdraw method as well. So it's time consuming for me. In this example, we have only two classes and where we have to make in two different places only. Just consume in your framework where you have this shotgun surgery coachman across your framework. Right? You first hectic problem would be first you need to find wherever the problem is occurs. Right? Then you have to do the refactor. At that time, you may miss to change in few areas as well. Right? So always avoid this type of code smell. And what could be the solution for this, right? First, you need to understand the single responsibility principle, and you need to refactor it in a way that a class should hold a single responsibility, and you should not overuse that. When you try to refactor the divergent change, right, you might have overused that refactoring technique like extracting like class. That's what here happens, right? We extracted the deposit service and the withdraw service for two different classes, which violates the single responsibility principle again. So what we have to do? So the refactoring technique would be the inline refactoring, which means if you have to do an inline method when couple of methods or more than a method operating with the same data, or you have to do an inline class when two or three classes holds a single responsibility, right? So in our bad code, we have our three classes which holds single responsibility. So we merged all the three classes into one. Now it holds a single responsibility, and which justifies the single responsibility principle, right? So with this, we completed this change preventers category. Before moving on to the next category, any questions, folks? Okay, I hope everyone understood sportsmen. Yeah, someone.
Hi, like you actually explained two code smells and you actually contradicted both of it. And if we need to follow one, like which we should follow, either we should follow both or we should follow one that
Okay.
is
The first thing is you should not follow the bad codes. So this is the code smell which you have to identify the bad code. You have to follow the principle properly here, which is a single responsibility principle. If you follow the single responsibility principle properly, you could have avoided these two code smells over there. So if you see the shotgun surgery, that's what I told, which is the over usage of the divergent change. If you over usage the divergent change, try to separate the classes irrespective of its responsibility, right? You will end up in another code smell, which is a shotgun surgery. Again, you have to do a refactoring, which has to justify the single responsibility principle. Hope I answered your question, Yoda.
yes, thank you.
Cool. So any other question, folks? Okay, so let's move on to the next code smell, which is the object-oriented abuses. I hope most of the people should have worked on the languages which follows the object-oriented paradigm here. So this category of code smell, which is specific to those languages which we use, main importantly the object-oriented concepts. Sometimes we start violating the object-oriented concepts by not properly implementing those concepts in the code, right? So let's see what are the code smells we have in this category. So the first code smell is a switch statements. Oh, what? Switch statements are code smell. So everyone would have surprised when you hear the switch statements is a code smell, right? Yeah. So, but in few use cases, the switch statements can be used. Okay. So let's see what is the switch statement. So before that, so we are often used to the switch statements, right? Because it is easy to implement and it gives more readability when comparing to the if-else statements, right? So it is so faster to implement. Is that easy to maintain? There is a big question over there, right? In fact, it is not. It's not easy to maintain over there. That's why it is placed as a code smell in this category. Let's see why it is not easy to maintain over here. So there are two use cases where you should look into the switch cases. when you are having a switch case which does only one behavior, right? When I say a behavior, see if I created a enum over here which has different shapes, right? If I have only this method, right, which does the calculation area, then it is good to have your switch cases because it is doing only one behavior with this type cases, right? When the problem comes, right, when you are using the switch case or if else conditions, more than one behavior, right? So which when it does a different behaviors, there comes is a code smell list, right? If you see this classes, right, the shape class, it has a enum where we have a different shapes over there, and we use two different methods, calculate area and calculate perimeter, where we are doing giving a different implementation for every shapes over here, right? So the problem here is when I try to add a new shape over here, right? I need to come here and add a new case here, as well as I need to find all the classes wherever I use this type case, right? I mean the type case of this enum, right? Then I have to go and make changes over across your code base. Again, this is a time consuming for you, and it's difficult to find wherever you use, right? So this clearly tells you, right, it's again violates the another principle, which is the open close principle. So what is the open close principle tells, right? A class or a method should always open for the extension but closed for the modification. If you see, I'm adding a case here, so it is not an extension over here, right? Because I'm modifying the existing behavior of this class here, right? So it is a code smell for sure, right? So what could be the solution in order to avoid the this smell, right? So whenever you have to you have a situation where you have to write a switch case or a sequence of if conditions, the first thing you have to come in the mind, it's a polymorphism. Hope everyone knows what is a polymorphism, right? Which does multiple forms, right? So let's quickly jump into the what is a clean code, what we have. So we just created an interface out of shape, and we mentioned what are the methods over there to calculate the area and the calculate the perimeter, and we converted all the type case to different classes. You see the shape circle, which inherits the shape, circle, which inherits the shape class over there. And it's giving its own implementation over it, right? Likewise, all the other shapes have been converted into a new different classes, and it is giving its own implementation over there. If you see, if I want to add a new shape, say called a triangle, if I want to add it, I can easily create a new class and I can extend the shape and I can give my own implementation, right? With this, we are not, we are justifying the open close principle where we are extending the classes, but not, we are not doing any modification to the existing classes, right? So any questions before moving on to the next question? Okay, good. Okay, let's move on to the next code smell, which is a temp field or a temp variable. So sometimes you have a class where you will introduce instance variables or temp variables, which is being used only by one method or in a limited situations, right? So those temp variables will be sit idle in the class all the time, except those methods getting interacted with those variables, right? So let's see an example over here. I have a product class where I have a few temp variables, which is in the class quantity, item price, discount factor, base price, and the total price, where I have a methods called get price, which is calculating the get total price of the product, which gets the input of quantity and item price, which is saving the setting up the data for these two local temp variables over here. So these two temp variables has been used in the another method, which is a base price, which is highly dependent on the get base price to set up the temp variables of quantity and item price here, right? So if you say another method is a discount factor, which is expecting a base price temp variable here, which has been setting up in the base price method, right? So, and it is discount factor is calculating the discount factor, and it is again storing in another temp variable, which is being used to calculate the total price over here. If you closely see this, right, all these methods are highly dependent on each other, right? So the base price is highly dependent on the get price to set up these two values, and discount factor is highly dependent on the base price to set up the base price value over here, right? And again, to calculate the total price, we need a base price and discount factor, which is highly dependent on the base price and discount factor. Oof. So many dependencies over here, right? So everything is coupled each other. So we need to think about why do we need this temp variable here, right? Why can't we pass that variable directly to this method, right? The calling method, right? Why we need to store this temp variable? Because of sometimes we thought, okay, it makes so readable, right? And just storing it in another temp variable and just passing it over there, right? So this is a wrong practice actually. So how to overcome this? You can directly pass this temp variable to the method as a parameter, and then you can use that. So let's see what is the clean code we have. So if you see this get price, we removed all the variables which we have in the class, and we just passing the input parameter directly to the respective classes over here. Quantity and item price has been passed to the base price, and once we get the base price amount, and it is being passed to the discount factor over here, and we are calculating the total price and passing returning back to the client, which is being called by this method, right? So this is a one use case where you should avoid the temp variables, right? So the another use case would be when you have a method which gets an input parameter as an object, right? Where you have another method which is calling inside that method, where you want to pass two values, which is from this, which is inside this object. Okay, what we will do, we will create a two temporary variable over here, and we will save those values in that, and we will pass those values to the calling method again, right? So this again, you should not use a temp variable over here, right? Instead of that, you can directly pass this object to the calling method which you want to use, right? So the method which can get the variables which they want to do, right? They can do whatever they want to do in this method, right? This process order method. So this is another use case where you want to where you should avoid the temp variables. Okay. So before moving on to the next code smell, any questions? Kowcik, any questions in the chat?
No, Kapil, we don't have any open questions. Okay. We'll move on to the next code smell.
Okay. So the next category of code smell, which is something specific to the UI test here. Right. So before discussing that, let me explain what is the application under test here. Right. So this is a simple one-page application where we have multiple books where you can filter a book and you can get the result of the book. Okay. So this is a simple framework which we created to demo this code smells. So these are the tests. So the test, if you see the test directory, which holds the test classes, as well as in the main directory, we have all the framework related codes over there, right? So if you see the base test, I'm just initializing the driver, and I am opening the URL and some teardown methods over here to close the browser instance, right? Sorry, driver instance. In a test, we have only one test where we have to search a book with the title, and we are just checking whether that search book is visible in the UI or not. Right. So let's quickly jump into the framework. So here we have one page class where we have a couple of locators over here, and we have a couple of helper methods, and we have a search function which is doing a search operation. First is clearing that and entering the text, and we are putting some weight over here. And another method is to check whether that book is visible or not by getting all the elements from the UI, and we are iterating that, and we are asserting that whether that search book is displayed over there or not. Okay, so let's with this we can move on to the smells what we have in this category, right? So the first code smell is flaky locator strategy, right? So when it comes to a UI test, right, the locators are most important thing we always look into it, right? Because we need a locators to perform any action on the UI, right? So having a stable locator is something we always tend to follow, right? So sometimes we may end up in having flaky locators, right? So which may lead your test gets more flaky as well, right? So let's discuss how the locator is getting flaky, right? So there are two locators which may make your locators get flaky. So one is a fragile locators and other is unreliable locators. So the fragile locators are something which could easily broken. So it will work for that moment of time, but it won't work for the longer period, right? So if you give a quick example on that, we may use some locator tools like a Chrome dev tools to fetch XPath or a CSS selectors from that, right? So if you see that, if you see this web page, right, it has a dynamic elements over here. If I am just taking an XPath or a CSS selector, which the Chrome dev tool gives, right, it will work only for that element when we search, right? What if I want to search on another book in that same time for the next run, right? It is not going to work over that, right? So this is again a code smell of which indicates that you should avoid the fragile locators. On the other end, we have unreliable locators, which is not a trustworthy, right? So to give an example to unreliable locators, in a XPath, we sometimes we go with absolute XPath rather than the relative XPaths, right? So absolute XPath are something in a DOM, the complete DOM path we will have it in the locator. If something some changes happens in the DOM structure, right? If the developers have removed one tag in between, it is not going to work. It's going to break. So these are the types which makes your locators get flaky, right? So in order to avoid this, to write a stable locator, what we have to do, what we need to follow, right? So always remember one thing. So when you find a locator, write a locator. The locator should be very simple, and that should uniquely identify the desired elements, right? So so with that, we have an order of preferences which you follow, right? So this is a locator strategy you should follow every time. The first set of locators would be the ID name and the class name. Always you should go first with these locators instead of directly jumping into the XPath or a CSS selector. First, just see whether this locators can be taken, right? If you have a static elements in the UI which attributes values are more unique, you should always go with the ID name or a class name. Then if you can't locate that element, right? If you have any dynamic elements, or that this is not gonna help you, right? At that time you have to go with any advanced locators like a CSS selector. Why CSS selectors over XPath, right? Their expressions are easy to write, and it is pretty fast when compared to the XPath, right? So go with the CSS selector before when you think about the XPaths, right? So still, if you can't locate an element with the CSS selector, then you can go with the XPath, but with one condition: you should not use any text function or the indexing for the anchors, right? So why we should not use a text function here, right? Just assume you have a UI which has multiple language options, right? Where you can change from English to French, right? When you hard code the text in your locators, right, it's not going to work when you change the languages, right? This is the one use case where you should avoid the text function. Also, the text function always fetch the text when that is associated with any anchors, right? Which means any tags, right? So it won't check for the descendants tags, right? At that time, you should replace the text function with the dot operator there in the locators. So the dot operator is used to locate even the text which is available in the descendants as well, right? So moving on to the indexing. So why we should not use the indexing, right? So because indexing is not trustworthy again, because if there is some changes happen in the DOM structure, right, it's easily gonna break over here, right? So always try to avoid the text function and the indexing for the anchors, okay? So coming to the next locator strategy, which is the link text or the partial text. Why this is in the 6th place, right? Because it always search with the text in the UI, right? The link text, it always search with the link text. Okay, so because the text often may be changed, the link text may often change in the UI, the developer may change the text as well, right? So try to find those links as well with the above locators. If you can't still find that, you can go with a link text or a partial link text locators. Okay. If you can't locate anything with the above 6 strategies, then you can use your regular XPath with the text function or the indexing. Okay, so this is what you need to follow. So let's quickly jump into our page and see what are the locators we have. So we have two locators, which is a ID and which is being a hex path. I think it looks good because we are using an ID. I hope it would be a static element. If you see this hex path, right? So I think this is not this is a coachman over here, right? So this is not over. So let's quickly go and inspect this and check what it's going to highlight over there. Okay, so it is highlighting this book, right? The Java for testers. Since we are passing a test data to validate the Java for tester book, we just took this XPath from the by copying that from the Chrome Dev Tools, right? What if I want to search on another book in the next run, right? It's not going to work. It's again going to go break, right? Your test case is going to fail over there, right? So this is again a static XPath, which you always avoid. This flaky locators, right? You should always avoid this, right? So how we can overcome this, right? Before that, we'll just go with our order of preferences, what we have. Let's see what do we have any ID name or a class name in this. We have an ID, but it is a dynamic thing. It's keep on grows whenever we see a new book in this UI, right? Also, we have a class name over here, but it is not a unique, right? If you see this first book as a UI first child and the last book as a UI last child, and there are 3 hidden elements as well, which is not required for us, right? So let's see, we don't have a name as well here, name attribute. So let's see what is what we can do with the CSS selector, right? So the one thing, the best practice we should follow, right? You should locate an elements whatever you require, right? So if I just pull all the LI from this ID product list, right, it is gonna give me all this element where I need only these 5 elements, right? Why do I need to get this hidden elements and all? So the best practice would be try to avoid this hidden elements from the locator perspective itself, right? Rather than getting that into a code and doing an iteration over that. So like just write that in a CSS selector. So this is in a LI tag and just putting a colon over there and using a not function. And I'm going to see what is the unique class over there. So I need to avoid this, right? That's why I used a not function here. And I'm going to get these repeated things over at the class from the class name. I'm just putting a dot to specify it is a class and UI screen hidden. So with this, we are avoiding, we are not taking these 3 elements which are hidden, and we are just fetching only these 5 elements over here, right? So this, we can replace this in our test. And I'm gonna change this to a XPath from the CSS selector, right? So now it looks good, right? So this is the this is about the coachman of the flaky locators. So just be remember with this order of preferences where you need to follow, right? Instead of directly jumping into the XPath, first try to understand this order of preference and go in this order. So before moving on to the next coachman, any question, folks? Okay, I'll take it as no. And let's move on to the next coachman, which is the indecent exposure. Okay, what is this indecent exposure, right? So when you have a class, or let's take this a page class, right? When you have a page class, which has a variable and the methods, which returns the web elements, right? That's a coachman of this. Because if you see the test class here, right? The test class responsibilities do pass a test data to the framework and get some result over there and do the assertion, right? But it is not its responsibility to look into this, get the DOM specific elements, which is a web elements, right? If you are exposing that that specific DOM elements from the framework to the any test classes or any outside the classes outside from your framework, right? That's a coachman of this indecent exposure. You should not expose this. And also it violates the encapsulation here, right? Because if you see here, right, encapsulation, you should hide your data over, right? So we are not hiding here. We are just having this in a default way. So, or sometimes we can have it as a public as well, right? Which means the outside the folders also can able to access that, right? So in order to avoid this, we need to mask this with the private, right? We need to encapsulate this. If you read this code, we have a 2 locators which is being explicitly exposed to the outside world. Also, we have 2 methods which is retaining a web element which is also in a public, right? So we need to change all this thing to a private, right? Even we can make this as a private so that outside world can't access my driver instance. Yeah, right. So this is the code smell about the indecent exposure. Let's move on to the next code smell, which is the inefficient wait, right? So what is this inefficient wait, right? So we always try to handle our wait, right, with respect to the elements what we want to display, what we want to look into in the UI, right? So when you are using a hard-coded weight or a static weight in your code, that gives this smell. Okay. So why you should not use this, right? First and foremost, it slow down your runtime, right? Because sometimes the elements which you're looking may get visible within 2 seconds, where you put a wait for 5 seconds, you ask your test to hold for another 3 seconds unnecessarily, right? And also the another problem here is, just assume like you are running the entire scripts in the pre-prod environments, let's say a QA environment, right? Where you see like the element is visible in the 5 seconds, where you want to run this entire scripts in the production environment, where it's just loaded within 2 seconds, right? So again you are unnecessarily waiting for another 3 seconds, right? So this is what this smell is all about. This is causing a problem. So how to get rid of this, right? So we need to go with some dynamic weights. Since I'm using a Selenium over here, so Selenium provides you a WebDriver weight, which is a explicit weight and the fluent weight where you can use in this case, right? So here I'm using explicit weight because it holds many conditions over there here, and where we can wait for the element with respect to those conditions, visibility of the element or a presence of element or a clickable of element, right? Also explicit weight will look for the DOM for every 500 milliseconds for the element which is visible or for the given specific condition is satisfied or not. Also you can use a fluent weight where you can give your own condition over there, as well as we can ignore the exception, and we can modify the pooling seconds as well, right? So any questions with this?
So Kapil, we have an open question related to the locator strategy.
Okay.
So Prashant had a question. So if we have the UI which is being frequently changing, what should be the locator strategy? So considering Angular and all, right, so they are not going to expose unique ID and class. How do we decide the locator strategy?
Yeah, so if you see the order of preference, right, if you can't locate that with the ID or name or class, the first and foremost, you're going to go with the CSS selector, right, where you have some attribute which gives you static things, right? Then you can write with that CSS selector. If still you can't find, you can go with the expert over there. If where you have data tables over there, right, where you tend to find an element with comparing to the another element, right, there you can use expert would be the best approach over there, right? Because you have to pass on text and you have to check for another column which shows that text, and you have to find the element in the another column, right? Hope that answers Prashant, or still you have any queries on that?
Yeah, Kapil, I do have one question.
So to precise Kapiletion's point, sorry, am I interrupting in between?
No
Sorry,
question.
Okay. So to precise what Kapilation has said, so this should be the order in which we wanted to identify the locator when we are working on a UI-related automation. The priority should be ID followed by name, so then CSS and the XPath. So most of the situation we may end up in taking XPath the first instance itself. So that is what we are trying to come up with here.
Okay, thank you.
Prashant, did we answer your question?
Yes, Kapil.
Thanks. Cool. If we don't have any question, we can move on to the next code smell, which is the multiple points of failure. So what this code smell tells, right? It tells about the responsibility of the test and the framework, right? So we have a framework in the main folder directory, and we have a test classes in the test directory, right? So the framework job is to pass the state of the things, right? So it has to pass the fetch the data from the UI, and it has to pass to the test, right? But if the framework's doing the assertion, right, that's the code smell over here, because it is not responsibility of the framework to decide the fate of the test, right? It should not do that, right? Also, what is the problem over here, right? We can't reuse this check is book visible method again, right? Now I have a test, a single test over here to search a book with the title. What if I want to add a new test where I want to search a book with an author name, right? I can reuse this method, right? Since we have an assertion over here, we can't do that, right? So this is another problem for having the assertion in your framework level, right? So always try to avoid this. You have to be remember, like you have to keep your assertion, do your assertion always from the test side, not from the framework side. Framework job is to only provide the state, not to decide the fate of the test. Okay. So this is the code smell, which is what we have to do. So we have an assertion here. So we can move this to a test. And okay, this is going away. So we can change this to this. We can remove this and we can quickly make the changes in this method as well. So it has to return the Boolean and we don't need this. And we can return true if it outside the loop, we just change it to a false, right? And also we can name this given proper name, this book visible, right? So this is how we have to have your framework codes and the test classes separately, right? It has to do its own job, right? Based on its responsibility, right? So with this, we can move on to our last code smell, which is the hard-coded data, right? So what is this hard-coded data is telling you, right? When you have a test data which is hard-coded in the test classes, right, or it could be in a framework as well, right? It's not a good way to hard-code your data. Why? Because let's take a example which we discussed in an efficient way, where you want to run the same script in multiple environments, right? You can't find this, you can't expect the same data which could be available in all the environments, right? So so hard coding the test data is always a headache for us, right? So try to avoid this and extract this test data to some external files. You can have that over there, right? You can use some external files called JSON or Excel files, or even a property file would be better solution for this, right? The only thing is you need to keep remember, like try to extract this test data and try to move the test data from your code level. Okay, you should not have any of the hard-coded data. You should not see any hard-coded data in the framework or the test layers. Okay, so also there could be a situation where you have to deal with the sensitive data like a username or a password. For that, you can you should not extract that to this external files, where you have to go with the environment variables. You can have an environment variable and you can set up your username or a password, the sensitive data over there. So what I'm going to do here is I'm going to create a property file, and I have a helper class over here to deal with the property file. So I have created a property file here where I moved this test data over there. If you see the base test, I am having the URL. So the URL is often changed. So I'm just making this as, I'm gonna set this as an environment variable. So I just replacing over here. So this is some similar to the username and password. You can do the username and password like this. You can set up in the environment variable. So where I set up this, since I am running in ID, I'm just configured in this level itself. So we have in the environment variable like this. So what I'm going to do with my test data, I'm already have that in my property file. I'm going to call that using this method get value over there. I'm just going to replace over here. Right. So with this, we can avoid the hard-coded data in your code base. And there could be a situation where you have to run the entire suite in the pipeline, right? At the time, will this strategy help? Of course not, because often you have to change your test data based on the run, right? If you're running for a specific test in a specific environment, you have to come and change your test data, right? So if you're doing that and committing and pushing the changes into the repo, every time that the pipeline is going to trigger, right? So if you are in that situation, try to move your test data to any cloud storages. If you are using AWS or a GCP, you can move to your any of the cloud storages, and you can use any of the cloud storage clients to access the storage, right? So with that, you can avoid having uncoded data, and you can also separate that from your code base, right? So we have done some refactoring over here, and just we try to run this test once after the refactoring. It's so important that every time you are doing a refactor, right, you have to run your test again, because it should not break any of the test flow, right? Because you are making a changes in the internal stuffs, right? You are refactoring in the internal stuff. It should not break any of your external behaviors. Okay, so our test got passed. So that we also removed all the bad codes and make it as a clean code over here. So with this, we come to an end of this demo. Any questions, folks?
Yeah, Kapil, Prashant here. I do have one question.
Yeah, Prashant.
Yeah, Kapil. So sometimes it's like, right, so you are saying that we have some credentials, like something information which we cannot expose to any static file like properties file or anywhere else, right?
Yeah. Exactly.
So you are saying that we can pass it as an environment variable. But
Yeah.
what's happened, it is found that most of the time when we are working in a scalable environment, such environment variable used to create a huge mess. So how we can overcome this situation?
Okay, in that time you can use any secret managers. So the GCP and all are providing a secret managers. So you can get your secrets over there. So you can use an environment variable for change. Just to give an example, if I want to run the same scripts in different environment, where I can set up an environment variable to give an environment names like a prod, or if I want to run an account or a UAT like that. So, to begin with that, I just give an example of you can keep your secrets in your environment variable, but you have to run in a pipeline or to run in a scalable environment. You can extract that into any secret managers like that.
Okay, yeah, perfectly fine, Kapil. Thank you.
Thank you. Yeah. Any question, folks?
Right. Thank you so much, Kapil and Kowcik.
Yeah.
So, team, let's take a quick lunch. I'm sure everyone is tired. So let's try to come back by 2:30, and we will have a hands-on session. So Kapil, would you like to quickly explain how the hands-on session looks like?
Yeah, sure. So we have a framework over here, which follows a page object model we created with the Selenium and Java. So we have an application called a source demo, which we automated with a one flow where we are going to purchase. I'll just show you the flow as well. So this is the application. Yeah. So here you're going to add some product in the cart, and we are going to navigate to the cart, and here we are going to validate this product name and the format of this price, and in the checkout we are going to give our shipping details, and this is a simple application and a simple test we have written. Here we are going again validating the product name and the price, and we are finishing, and we are just validating the confirmation message over here. So for this we have just written a few pages, like all the pages here. So every class has some bad code over here. So our exercise is to what are the code smells which we learn now, which we are going to put that in a practice, and we are going to clean up this mess. Okay. So for this, we are also providing you a cheat sheet, which will guide you throughout this exercise, where you can know what are the code smells and what are the symptoms and what could be your refactoring. Also, we speakers and other trainers also will be here to help you.
Awesome. That sounds really exciting, Kapil. So looking forward to the workshop. So I think let's take a quick 30 minutes break. I think it's 2:04. Let's connect back at 2:35 p.m. on the same channel. So yeah, thank you so much, team.
Thank you, folks.
We'll resume at 2:35.
Have a good lunch and come back.
Yeah, thank you.
Kapil, I have a question.
Yeah, Ravi, sure.
Kapil, please can you share that code where you had the batsman and the clean code?
So what clean code you are asking? I didn't get that.
Please can you share that code repo, like for
Okay,
the bad code and the clean code.
Okay.
Yeah, repo.
Sure.
It will help quickly
Yeah,
to.
yeah. I'll do that. I'll do that.
Yeah, thank you. It was very nice. It was very nice and engaging. Yeah, thank you, Kapil, and thank you, Kowcik, very much.
We can expect you for the exercise, right?
Yes, yes,
Okay.
yes. In fact, I'm traveling and I don't want to miss this workshop. So I'm on the mobile phone and I'm listening to you.
Oh, okay.
It's nice hearing, Ravi, that you are still attending the workshop even when you are traveling. Interesting.